What if gluten-free wheat is an option? If dwarf oil palm trees replaces full-size trees? And if paddy farmers are lifted out of the B40? These are advances in biotechnology to lift communities and address food security in the age of climate change. Food production generates a third of man-made greenhouse gas from clearing of land, rearing of livestock, and production of fertilizers.
The fertilizer issue is complex in many respects because not only there is a lot of carbon footprint to produce reduced nitrogen, we have to use a lot of heat to break the triple bond of nitrogen, and then you have to make hydrogen. Hydrogen is usually made from methane by breaking the methane into carbon dioxide and hydrogen. And that hydrogen and then nitrogen, they have to combine and make ammonia. So that's how Haber and Bosch, who were awarded Nobel Prize for their seminal discovery in the early 1900s, they came up with synthetic fertilizer.
Instead of synthetic fertilizer, biotechnology offers two interesting concepts.
One called a cover crop and the other called a cover microbiome. So the cover crop can be a legume which we plant when the growing season is over. All that we are interested in that legume to do is to grow and create nitrogen fertility. And then when you come back in April, May and grow soybean or corn, there is already a lot of fertilizer that has been built using the tools of nature. What the cover microbiome does is something very similar, where you spray the microorganisms that live on the root surfaces, which take the carbon that is exuded by the root and use that carbon to fix nitrogen.
These are inexpensive technology to improve soil health and reduce carbon footprint.
What you do is basically grow the microorganism and then spread the microorganism either by spraying it into the field, or you can even coat the seed with the microorganism so that when you plant it, the microbe actually comes with it. And when you do that, the cost of the solution is not very large, because if you plant, in the case of corn, let's say 80,000 seeds per hectare, all those 80,000 seeds come with their own packaged microorganism. And then you can add either synthetic nitrogen, or now you can actually spread the field with a small dose of microorganism which can take sunlight and fix nitrogen. So the combination of the two basically eliminates the need for having natural gas. They also make other co-products which improve the structure of the soil. They also make water-holding molecules. They improve the extractability of phosphorus. So we are beginning to understand not only the plants that can contribute to agriculture, but the microbes that can contribute to agriculture and soil health. And this concept of microbes being used and plants being used is applicable to all land. Imagine if we had actually destroyed the quality of soil in a given area and walked away from it. And now we can bring these microbes and cover crops to build up the fertility. It is going to be a very valuable contribution.
In the fields, not all growing conditions are equal, and a farmer's insight to his land can further improve productivity.
We tend to look at every acre and say, you know what, if we are growing 1 acre of rice here, if we have 100 acres of rice, all 100 acres are equivalent. It is not so. There may be acres within that 100 acre where there is water logging, because underground maybe the water is channeled towards that region, or it could be that the fertilizer is rapidly washed away from that region, or maybe there are more pests in a given region, or some other event that makes that soil not as uniform as we think. So we can also begin to customize these things using biology to customize, as opposed to using a combination of drone sensor technologies and all kinds of modern energy-intensive technologies.
Beyond protecting the soil, a challenge that comes with climate change is the rising sea levels.
We have to certainly make crops saline tolerant as well, because there is a fair amount of land already that is saline, and there is no reason why we should discard them. We should be breeding crops using modern technologies to make it saline tolerant and drought hardy and flood tolerant as well. Because with climate change, you don't know which combination we will need. One of the things that I must point out is that by making dwarf plants, you also protect the plants by having deeper root systems, so you can prevent lodging because of wind damage. You can also have the ability to draw water from deeper underground, draw the nutrition from deeper underground, and so forth. So in the United States, in most of the parts of the Midwest, it is cold. It snows until about April, May, and then we have in November the onset of the cold season again. So within those few months, the growers have to get into the field, get the crop planted, and make sure that the crop develops, and then they harvest the product. U.S. has done an excellent job in agriculture this way, and U.S. has been responsible for 20-30% of the grain that is traded in the world market because of that efficient agriculture. Now, what happened in South America when we took that technology is there are parts of South America where the temperature never gets below freezing. In those regions, they are able to grow soybeans 3 times. But the issue is, if you grow the same crop 3 times in a growing season, what is it doing to the soil? What is it doing to the pest ecosystem and so forth? So what the growers tend to do is rotate these. For instance, if you grow corn now, then maybe you should rotate with soy, or maybe you rotate that with alfalfa and reduce the dependence of corn on the synthetic nitrogen fertilizer. So these are some of the practices that are being already followed through. What the gene technology can do is to shorten that life cycle of these plants, so that from seed to seed, if you were taking 100 days, imagine if you can do this in 80 days. All of a sudden it opens up opportunities for superior management.
And if these regions can manage 3 harvests a year, can we increase paddy cultivation from 2 to 3 harvests? Currently at 70% self-sufficiency, we import 30% of rice valued at 1.5 billion ringgit, money that can be better channeled towards local paddy farmers who remain in the B40.
So we have to be asking the question, if MARDI, if Rubber Institute, Oil Palm Institute, if they are enabling the citizenry, the farmers of the nation to benefit from the biodiversity that exists. So the germplasm collection, the screening of the germplasm, figuring out if we should be domesticating some of those other crops, technology that is tested and developed in these other crops which are faster cycling, we can then move to rubber, oil palm, and also ask the question, how do they work in those systems? But then they would have been validated already, so the risk is even lower.
The emotions of genetically modified food are keeping certain products out of certain markets.
Politicization of everything has occurred, but when science gets politicized, the world begins to have polar views on whether something is good or not. These gene modifications, it is nothing but an extension of what we have been doing in history, and that they are tested, their safety is assessed. This is why the farmers are embracing the product, because they deliver a useful function. Wheat actually has not seen the benefit of GM technology at this point of time at all. So we can actually create low gluten, high protein wheat.
And the role of government at large
is to provide a view on whether the technology is safe, whether the practices are safe, whether the products can be consumed locally or deployed globally. The government can also study the impact of the technology, make decisions on whether they should be promoting, subsidizing, because in early stages of technology development, it takes work. The government also should create what I call an enabling environment. If they stand in the way and say no, no, no to everything, then sooner or later, the talent will go elsewhere. So for Malaysia, it is most important that there is that collective ownership for implementation, collective ownership for action, and that collective ownership for fast tracking these kinds of things instead of debating endlessly about whether this is good or bad.
And perhaps protectionism is not a way forward.
I believe that what we have is a very paternalistic view of protecting the smallholder farm. They don't want to be protected. They want to be given the opportunities. They want to be shown the possibilities. It is our job to actually have the dialogue with the smallholder farmers, see if they want to remain a smallholder farm or they want to grow. If they want to grow, we should provide the tools. We can take the baby steps towards doing this so that we don't have to risk lots of money. This is what the micro loan concept was. Many people have come out of poverty in many parts of the world based on those type of microfinancing possibilities. The smallest farmer, they don't want to remain poor. If we can make their life easier, so smallholder farms, if they don't have to spend as much time scouting for insect pests, scouting for whether the fertilizer is applied properly or not, if the plants that they grow are drought hardy, deep roots, things of that nature, then they can make their life a lot easier.